Hello friends, how are you doing? Welcome back to the channel. My name is Desmond, final computer science student from University of Malaya. Today we will talk about the CSO Lab 3 flip-flop. So the task is to build a D flip-flop. And before that, we need to understand what is a D flip-flop. So a D flip-flop, let me just demonstrate. So a flip-flop is activated at the edge. So it's called edge activated. Okay, so let's highlight all the edges over here. In this case, we are talking about a flip-flop that is activated at the rising edge. So this is the rising edge, right? So this is the rising edge and this is the falling edge. So we are talking about this part, the rising edge. So a flip-flop can either be rising edge activated or falling edge activated. But in this case, we're talking about rising edge activated D flip-flop. Okay, so let's highlight all the rising edge. Okay, so this is the clock. We're talking about the rising edge of the clock, and this D is our input. All right, and this Q and Q bar are our outputs. So this diagram is called a timing diagram. Now what we would do here is we would try to write out the output for Q and Q bar according to the clock and D that's given. So let's start on the first rising edge. So in this first rising edge, we're going to see what's the current D. So if the D is at 1, then this would be 1 until the next rising edge, right? So we can ignore everything here because we only read the input of D when it is a rising edge. So basically this part over here, you can think of it as being ignored, or the component is sleeping, whatever you like to think. So this part over here we can ignore, and ignore. This part is the same. So until the next part over here, we're going to check again, because this is the rising edge again. We're going to check at the input D again. Now it's at 0. So this part over here would be 0. Okay, until the next rising edge. So in the next rising edge, we're going to check the D again. So it's at 1. And we are going to draw a straight line over here until the next rising edge. Okay, so at this part, D is at 0. So this is how we draw the output of Q. And Q bar is just the invert of Q. So we can just, when Q is at 1, it should be at 0. And then when Q is at 0, it should be at 1. So just a mirror image of Q. So this is for Q bar. Alright, so for D flip-flop, we actually have two inputs. One is the clock and one is D. And for the output, we have Q and Q bar. Q is dependent on D at the rising edge. Okay, at the rising edge. And Q bar is just the invert of Q. Alright, so by now I hope that you understand what the D flip-flop is doing. So let's move on. So this chip over here, the 74LS175, is actually a chip for the flip-flop. And this is the truth table for the flip-flop. So we can ignore the clear for now. Okay, we just set clear to H, to high. And we should focus on this 3. So the clock, this is a upward arrow. This is also an upward arrow. This is low. During a rising edge, when the D is H, then the Q should be H and the Q bar should be low, L. And during the rising edge, when D is low, then the Q should be low and Q bar should be high. So Q just follow the input of D during the rising edge, right? And when it's not in rising edge, no matter what's the input of D, we remain, this is just meaning that no change. We show the previous state of Q and Q bar. The pins that we are going to use for this exercise is CRR, VCC, and also Q1, 1Q, 1Q bar, and 1D. Also the ground and CLK for the clock. Alright, now let's move on. Okay, now this is our truth table, and we are now going to show you what are the components that are needed. First of all, we are going to have VCC, ground, and also a switch. So we are not going to connect this CLK to a clock. We are just going to simulate the clock using a switch over here. Besides that, we are also going to need the LED, two LED for the output like the previous labs, and the LED also would need the resistor to lower down the current that passes through the LED to prevent it from burning. Now let's connect the circuit. So, right, like usual, VCC should be connected to the VCC chip, VCC part of the chip, and ground should be connected to the ground of the chip. And for clear, we are going to connect it to the H, which is VCC. And then we are going to have the input 1D over here, which can be connected to either the VCC for 1 or ground for 0. Okay, so the H actually means 1 and L actually means 0. So it's 1, 0, 0, 1, 1, 1, 1, and 1. Alright, so the 1 is actually equivalent to H and equivalent to VCC. 0 is equivalent to low and equivalent to ground. The output, the Q1, we are going to connect, the 1Q, we are going to connect it to the LED positive terminal, and then from the negative terminal, connect it to the resistor. And for Q2, the 1Q bar, we're going to connect it to another light bulb, another LED at the positive terminal. Then the negative terminal is going to connect to the resistor. Now the resistor, of course, going to connect to the ground. Same to the other side, to the ground. Alright, now we are going to do the circuit for the clock. So the clock would have connection from the VCC, okay, to the switch. So this is actually a push button. Now this push button is going to be connected to the clock, CLK, and the resistor. And the resistor is going to be connected to ground. I will explain more about why should we connect this to the ground. So this is actually called a pull-down resistor. I will explain more at the end of this video. Okay, so this should be our complete circuit. So how this works is when we connect the 1D to VCC. Let's say D is 1, okay, and then nothing would happen. So this both of these would still be at the previous state, and we would push down this button or connect or close the circuit. Then when we close the circuit during that very split second, it has a rising edge for the clock, right? Because when this circuit is down, current will flow through here to the clock, and there will be a rising edge occurrence. When the rising edge occurs, then this Q would light up and this would not light up, right? So similarly, when we connect this 1D to 0, then we push down this button. This would have a rising edge, and then we would have this light bulb lights up and this won't light up. So this is the demo for the D flip-flop, and I assume that everyone would know how to put this on the breadboard already because it's already at the third lab. So if you are still unsure on how to connect it to the breadboard, try to watch my previous videos, maybe lab 1 and lab 2, on how to build it on the breadboard. Okay, so like I said just now, I will talk about the pull-down resistor. So when we are connecting a switch to clock, when we do it like this, if we don't connect it to the resistor, when we push down, the clock will receive a 1, right? When it's not, it might be 1 or 0. We call this floating. Due to some impedance, it can actually be 1 or 0. It's actually undefined, if you could say. When it's pushed down, when this button is pushed down, it's a 1. When it's not pushed down, it can be 1 or 0. So this is the problem. What we want is when it's not pushed down, we want it to be a 0. Okay? So this is how we are going to fix it. Let's do the circuit again. From VCC to the switch, and then from the switch to clock. Now we are going to connect it to the ground directly. Okay. Now, when it's not pushed down, the circuit is connected to ground, isn't it? Right? The circuit is connected to ground means that when it's not pushed down, the CLK would receive a 0. Okay. What if it's pushed down? So when this is pushed down, the current would directly flow to ground. Okay, so now when it's pushed down, the current is floating. So at the clock, it can be 1 or 0. So this is the problem. Why does it goes back to ground, right? Because this path has less resistance, and currents would flow through a path that has the least resistance. So when it's pushed down, even though when it's pushed down, this is connected to here and the ground, but the current would have a chance to go to the ground, right? So the solution for this, use a green color, okay, we would connect this to a switch, and then this switch will connect it to a clock, and then we will connect it to the resistor. So what happens now? When it's pushed down, okay, when it's not pushed down, this clock is connected to ground. So it's a 0. When it is pushed down, now the circuit is connected, this current will not flow through the ground because of this resistance. We have added some resistance over here, so the current would flow through the clock. So it will be a 1. So this is the importance of this pull-down resistor. So whenever you are going to have a switch, over here you need to connect it to a resistor before connecting it to the ground. Now we have shown how to do the D flip-flop. Let me explain a little bit about how can we go on to build the JK flip-flop. It won't be shown in this video, but I hope to give you some intuition on how you could build it yourself. So if you look at the truth table, the D flip-flop, this is for D flip-flop, this is for JK flip-flop. So the D flip-flop has 3 inputs, while the JK flip-flop has 4 inputs. The extra input is J and K, while this only has D, right? So the only difference between D flip-flop and JK flip-flop is that in D flip-flop, during the rising edge, if D is H, then Q would be H and Q bar would be the inverse of whatever Q is. And during the rising edge, when D is low, then Q would be low and Q bar would be high. While for the JK flip-flop, during the rising edge or the falling edge, when J and K are both low, they will stay at the previous states or no change. When J is H, then Q would be H and Q bar would be low. When K is H, then it will set Q bar to H and Q to be low. When both are H, when both are high, then it will toggle. Toggle means that it will change H to high to low and low to high. So if the previous state is H, then the next state after the HH rising edge or falling edge, then it will be changed to low. And when the previous state is low, then during this, if this condition is met, then it will be changed to high. So that's it for the JK flip-flop. You could go on and build it on your own, and hopefully you get the answers as shown in this truth table over here. So thank you so much for watching. If you like this video, remember to subscribe, like, and comment down below, and share it to your friends, because sharing is caring. And these videos take me a long time to build. If you consider to buy me a coffee, you could go to buymeacoffee.com/dio or paypal.me/dio123. Thanks so much for watching, and hope to see you guys in the next video.